Let's start tuning the PID controller, for example, so that we get better steady state early enough. So we can change the PID gain values here. It's a default of 110, and we can manually try doing it, but like I just insert 555 for each of the gains. And if I run my simulation, it's better than the previous. And you might spend some time to find the best possible combination. But I'd like to use this tune button, which it invokes a PID tuning tool. It's a part of SIMULINK control design product. When I click that, it opens up a nice UI where it visually shows me how the response should look like. Okay, so just to be clear that this PID controller block is included in SIMULINK, but if you want to open up this automated tuning tool, that's here. That's available if you have SIMULINK control design. As you can see here, the dotted line is what our block is currently doing, and the solid line is how we want our block to perform. And we can adjust those the way we want the block to perform by just moving these slider values. So let's make it a little faster. So that way it reaches steady state faster. Once we are happy with this response, we can simply click on update block, and I think that's the best part of this tuner. We had 555, now it's these values. It should have been extremely difficult to guess for a specific response if we want to look at. Without that tuning button, I would most likely have just kept changing values, pressing OK, pressing play. Just keep iterating back and forth. This just makes it easier than doing that. So once we have that, we can verify that in simulation whether the response is showing in simulation as well for that plant we choose. So that's basically, how you would tune your controller and look at the results.